Hello everyone, I am back with a new lesson of a science class 10th, chapter number 1, gravitation. So students, let's start a lesson with few questions. First question is, what are the effects of force acting on an object? When we apply force, okay, when we apply force on a particular object, so what happened to that object? It will start moving, or it will change its position, its change shape or size. Okay, so and next question, what types of forces are you familiar with? So there are different kind of forces which are acting on different types of object, like magnetic force, electrical force, and many more forces are there. Okay, third, what do you know about the gravitation force? So this is our lesson about the gravitation and gravitational force. Okay, now what is the gravitation, student? So this phenomenon of gravitation was discovered by Sir Isaac Newton. Gravitation is the force of attraction between any two bodies in the university. So student, as the story goes, Isaac Newton discovered the force by seeing an apple fall from a tree. So apple fall from a tree on the ground. Okay, so the sir was wondered why all apples fall vertically downward and not at an angle to the vertical. Why do they not fly off in a horizontal direction? Why they are falling only in downward direction? So after much thought, he came to the conclusion that earth must be attracting the apple toward itself. That means in earth some force is there. Okay, so due to this force, earth is attracting apple towards itself. So what is this force? This is a gravitation. So gravitation is a force of attraction between any two bodies in the universe, and in universe each object attracts each other with a certain amount of a force, but due to the very weak nature of this force, usually we are not able to even feel it. So this is very weak kind of a force, but it is still there, and due to this force only two bodies in the universe attracting each other, and the large distance of separation is the main reason for its weak nature. So this is the gravitational force directed in the center of the earth, and this is directed vertically downward direction. Next topic is circular motion. So what is it? Movement of an object along the circumference of the circle. Okay, movement of an object. This is an object of any mass. This object will move along a circumference of the circle. This is called as a circular motion. Okay, now here we have type of a force, that is a centripetal force. What is it? It is a force acting on a body performing circular motion. Okay, it is a force acting on a body performing a circular motion, and it is directed towards the center. Okay, so this force will direct it towards the center of a circle. So this is a centripetal force, and a student, as this force is directed towards the center of a circle, this is also known as this is a center seeking force. Okay, now the formula of centripetal force, FCP is equals to mv square upon r, where the terms are, now FCP is a centripetal force, m is the mass of an object, v is the velocity with which it is moving along a circumference of a circle, and r is the radius. Now our next topic is law, Kepler's law. So there are this Kepler's law is basically the law about the planetary motion. So there are three different laws of which derived by the Keplers. He stated three laws describing planetary motion. Okay, so student, this is an elliptical object, and at this place here the sun is present, and around the sun a planet is rotating. Okay. So planet journey will start from point A to B, then C to D, and E to F. Now let's look at the three different laws by the Kepler. So first law of Kepler was the orbit of a planet is an ellipse. Okay, the orbit of a planet is an ellipse with the sun at one of the foci. So ellipse, we know that ellipse have two foci, right? So, and the orbit of a planet is an ellipse with the sun at one of the foci. That means sun will present at one of the foci of an elliptical orbit. So this was the first law. Now second law is the line joining the planet. Okay, the line joining the planet and the sun sweeps equal area in equal interval of time. Okay, the line joining the planet, okay, this is the line joining the planet, sweeps equal and the sun sweeps equal area in equal interval of time. It will cover equal area in equal interval of time. Third law of Kepler is the square of its period of revolution. Okay, the square of its period of revolution. That means period of revolution is a period which required to complete revolution of a planet around the sun. Okay, so square of the period of revolution around the sun is directly proportional to the cube of the mean distance of a planet from the sun. That means t square is directly proportional to cube of mean distance. Therefore, t square is equals to kr cube, and this k is constant. So by taking t square upon r cube is equals to k, where k value is constant. So these were the three laws by the Keplers. Okay. Now Newton's universal law of gravitation. What is it? Let's understand. The law states that every object in the universe, okay, every object, it can be any object in the universe, attracts every other object with a definite force, like force of gravitation. Okay, so gravitational force is there, so every object in the universe attract each other with a definite force. That means some kind of force is there, and this force, okay, the force which attracting every object towards it, and this force is directly proportional to product of the masses. So here two different objects are there, so product of their masses, like first object and second object. Okay, so product of the masses, and second, it is inversely, so the same force is inversely proportional to the square of the distance between them. Okay, now this is a statement of the law. Now let's have a look on derivation. Okay, so here two different objects are there, and their masses are also different. Okay, and this is a force by which two different objects are attracted by each other, and this is a distance between two different objects. Now what was the statement? The force is directly proportional to product of the masses. Product of the masses, this is a first object, second object, m1 into m2, and it is inversely proportional. Okay, inversely proportional to square of the distance between them. Now this is a sign of proportionality. Now we can write it as F is equals to, or force is equals to, force is directly proportional to product of the masses, and it is inversely proportional to square of the distance. Now this is a sign of proportionality. Now we can write that F is equals to capital G m1 m2 by d square. Now here what is G? This G is called as a universal gravitational constant, and the value of G is 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. And this value is discovered by, or measured experimentally, it is measured by Henry Cavendish. Okay, so this is a SI unit of value of G, which is 6.67 into 10 raised to minus 11 Newton meter square per kg square. Okay, now if the mass of one object is double, what is it? If the mass of one object is double, like we have two objects, right, m1 and m2, okay, so if the mass of one object is double, the force between two objects also doubles. Okay, why? Because masses are directly proportional. Masses are directly proportional to the force. Okay, so if the masses are double, then force is also gets double. Like here I have one short derivation. If mass of one object is double, then we can write as F is equals to G. This m1 is double, like 2 mm upon d square. So this is double, that means g mm upon d square. What is it? This is a force. Okay, F. So suppose this is F dash. Okay, so F dash is the double force. F dash is equals to 2F. So the force is also get double if the mass of one object will get double. I hope you understand. Okay, and next condition is if the distance is double. Okay, if the distance is double, like here r we can write d square also. So if this distance is double, then the force decreases by a factor of 4. Why it is decreases? Because force and distance, these two are inversely proportional to each other. Therefore, if the distance is double, the force will decreases by a factor of 4. Okay, now let's have a look for this. Okay, this is F dash is equals to gmm upon d square. Okay, so if the distance is double, d square, if distance is double, that means if d is equals to 2d, then 2d square will be 4d square. Okay, and what is this? This is again a force. That means F dash is equals to gmm upon d square into 1 upon 4. So if the distance is double, we have proved that the force also decreases by a factor of 4 because it is inversely proportional. Distance is inversely proportional to the force. I hope you all understood. Okay. Inverse square law. So this is law which is proven by Newton's law by using Kepler's third law. Okay, now what is this law? So student, if a planet is revolving, okay, so here I am drawing a diagram. If a planet is revolving around the sun, this is a planet, it is revolving around the sun, okay, in a circular orbit. So this planet is revolving around the sun in a circular orbit in a uniform circular motion, then the centripetal force will act on a planet towards the sun. Okay, the centripetal force will act on a planet towards the sun. So what will be this force? This force will be equal to F is equals to mv square upon r. This is a centripetal force. Okay, now and distance covered by the planet around the sun is equals to what? Is equals to circumference of a circle, which is circumference of a circle is 2 pi r. Okay, now let's prove this law, inverse square law. Okay, now speed of a planet of revolution. Okay, so speed of a planet is equals to distance upon time. Now I have told you distance covered by the planet is equal circumference of the circle or orbit. This is 2 pi r. Okay, now speed is equals to distance upon time, and this time taken will be 2, and here it will be 2 pi r. And centripetal force which is acting on a planet towards the sun, this is mv square upon r. Okay, now where distance d is equals to perimeter of the orbit, okay, which is 2 pi r. Now v is equals to what? Distance upon time, that means d upon time, and d just now I have told you which is 2 pi r upon t, circumference upon time taken. Let this be equation number 1. Now centripetal force, this is what? mv square upon r. Okay, now this is equation number 2. Now let's substitute value of v in equation 2. Okay, so we will get f is equals to m upon r, and v value is 2 pi r upon t. Multiply by 2 pi r upon t whole square. Okay, now let's do this square. M upon r into 2 square 4 pi square r square upon what? T square. Okay, so this is a force after substituting value of v. Now student, what is it? Okay, now cancel this. Now we will get new force value F is equals to 4 pi square m r upon t square. Now here we have to prove a Newton's law by using Kepler's third law. What is the law? The law is what? T square upon r cube is equals to k, right? T square upon r cube is equals to k. Now multiply. Okay, now let this be equation number 3. Now multiply and divide. Now we want this t square upon r cube. So here we can write multiply. This is multiply and divide equation 3 by r cube. Okay, just we are using Kepler's third law in this equation. So f is equals to 4 pi square m into we are multiplying and dividing. We are multiplying and dividing with r square, student, not with r cube. Okay, r square. Okay, now here we have r into r square. Okay, r into r square upon what? Upon t square into, again we will get here r square. Okay, okay, now we can write a equation which is f is equals to 4m pi square, 4m pi square upon, okay, let's look at here. Okay, 4 pi square m, r into r square will be r cube, and this divided by t square into r square. Now just write here into r cube divided by t square upon r square will be as it is. Okay, now we have Kepler's law as t square upon r cube is equals to k. Now but here we have r cube upon t square, right? So we can write here, therefore we can just inverse this, reciprocal this, take a reciprocal of this equation. We will get r cube upon t square is equals to what? Here k is there, so we will write here 1 upon k. Okay, now substitute this 1 upon k into this equation. So we will get 4m pi square upon r square into 1 upon k. Right, now write here 4m pi square r square upon k. Now student, this value, what is this? This is constant value. Mass is constant and these two factors are constant only. So we can write here f is equals to, so first write the constant value. So value 4m pi square upon k is equals to constant. So we can write here again f is equals to what? Constant. Okay, this whole value is constant, and here we have 1 upon r square. So we can write here f is inversely proportional to square of the distance. Okay, so student, this is nothing but inverse square law of a Newton. Inverse square law. Okay, now let's look the statement. Okay, Newton concluded that the centripetal force, okay, centripetal force which was acting on a planet towards the sun. Okay, so this centripetal force, which is the force acting on a planet and it's responsible for its circular motion of a planet, okay, must be inversely proportional to the square of the distance between the planet and the sun, which is f is inversely proportional to square of the distance. So student, this was inverse square law. Alright, now let's have a look on low and high tides. So you must be knowing about the high and low tides that occur regularly in the sea, right? And the level of seawater at any given location along the seashore. So this is earth and earth, and there is a water around the earth. Now student, this direction where moon is there, okay, and the gravitational pull of the moon on the ocean, this is this force, this arrow you can see, which you can see, these are the gravitational pull of the moon. Okay, so moon also have a gravitational pull of the moon on the ocean. This is the ocean and at pole, and this is at equator. Okay, so at this, high and low tides occur at different times at different places, and the level of the water changes. Level of the water changes due to the gravitational force exerted by the moon. Okay, so this high and low tide are causes due to the gravitational force which are exerted by the moon. Okay, now student, this for suppose this is an earth, okay, and this is a water surface around the which is surrounded the water. Okay, now as in this direction we have moon. Okay, so due to the gravitational pull of the moon, water which is directed towards the moon, okay, this is bulges outward. This water which is facing the moon, it will bulge it outwards. Okay, and this here the water level towards the moon will be rises up, and water level in the opposite, which for suppose this is a 90-degree angle. Okay, so at this position which is facing towards the moon, it water level will bulges or rises up, and at this position at up this direction which is at pole, we can say water level will be less. Okay, so here the high water level and here the water level is less. Okay, so water which is directed towards the moon gets pulled towards it, that means towards the moon, and water level rises up there, causing high tide. So at this surface where the water level rises up or bulges out, here high tide will take place. Okay, so water bulges towards the moon due to the gravitational pull of the moon on the ocean. Okay, and at this side, that means at opposite direction of the moon, water bulges away from the moon. Okay, so here also water bulges there, but it is away from the moon. So at these two places, at these places, okay, high tide will take place where the water level is high, and at the this angle 90-degree angle from the equator, water level is very less where low tide occurs. Okay, that is which is our north and south pole. At the two places on the earth at 90-degree from the place of high tide. Okay, so this is place of a high tide, and from the place of a high tide at 90-degree low tide will occur, because here the water level is very less. All right, and the place of high tide, the water level is minimum and low tides occur there. So this is all about high tide and low tide. Okay, now next topic is Earth's gravitational force. Earth attracts every object near it towards itself because of the gravitational force of the Earth, and mass of the Earth is situated at its center. Okay, mass of the Earth is situated at its center. So the gravitational force on any object due to Earth is always directed, okay, always directed towards the center of the Earth, and hence object falls vertically downward direction on the earth. Now we have one question: why do objects fall down after reaching a certain height? That means if we are throwing a object in upward direction, okay, so they will reach at particular height, then again they will come back after reaching certain height. Okay, so after reaching certain height from the earth, again they will fall in downward direction. So why this is so? When we throw an object in vertically upward direction, okay, in vertically upwards, so suppose we are throwing a ball in upward direction, so what happened? Earth's gravitational force, it will try to pull it down and reduces its velocity. That means due to the gravitational force of the earth, object's velocity, it will be reduces. Okay, and due to this constant downward pull, that means downward pull or gravitational pull is continuously or constantly it is acting on an object, and due to this downward pull, the velocity of the object becomes zero. So after reaching at this much height, the velocity v is equals to 0 after a while, and due to this constant downward pull, the object starts moving vertically downward direction towards the center of the earth, and under the influence of the Earth's gravity, under the influence of gravitational force only. So this was about Earth's gravitational force. So that's all for today.